Hi, I'm Harish. Here, let's talk about computer vision and image processing. Introduction. Introduction to computer vision. Computer vision is the field that enables machines to interpret and process visual data from the world. Like, it captures the through eyes, cameras, or lenses, or through robotics, capturing those images in the real world, capturing those moments or the environment or the atmosphere through the lenses, and then processing it to the digital form is called an image. And it combines the image acquisition, processing, and analyzing to automate tasks such as recognition and decision making. So this in this presentation, we'll be covering the fundamental principles essentials for understanding the computer vision applications and the modern technology which has been used using the computer vision. So let's talk about the fundamentals of computer vision. So image formation and representation. So the image formation involves the capturing light from the environment through cameras to generate the digital images. Let's say a camera which is capturing the environment with the help of light. So with the help of light, the object is reflected towards the camera, and then the camera captures that thing as an image, and that image is called digital image. So these images are represented as pixel matrix containing color and intensity data as well. So understanding how images are formed and discretized is crucial for further processing and analysis of the images as well. So feature detection and extraction. So what is feature detection and extraction? So feature detection identifies the key points or the patterns in the image, such as edges and corners. So which serves as an basis for object recognition. So let's talk about in terms of edges and corners, like a fingerprint image is there. So in the fingerprint, so empty spaces also will be there. So identifying those spaces with the help of pixel values. So basically converting the image into pixel format. With that, we can easily find out the empty spaces with the pixel values like 0 or the minimal negative values. So these edges of the fingerprint, which will be captured or identified or detected with the help of the feature detection. And the extraction techniques convert these features into descriptors that enable efficient comparison and matching across the images. Like after the feature or the detection, after the feature is detected with the help of edges and corners, so that extracted content will be uh, processed and used for the pattern matching or across the images, like fingerprint matching or face matching or facial pointing matching, etc. So camera models and calibrations. So camera models. So these describes the geometric relationship between the 3D object and the 2D image projection. So basically, the camera models or the calibrations will be like describes the relationship between the 3D object as and their 2D image. So these calibration correct lenses and distortions or aperture corrections and aligns the camera parameter, ensuring accurate spatial measurements for tasks like 3D reconstructions and navigations. So image processing technique. Let's talk about image processing technique. So in this, filtering and enhancement. So filtering plays a major role in this image processing. Like these will improve the quality of the image just by reducing the noise or just by enhancing the important structures. Enhancing the important structure, which includes the removing the extra space, uh, basically converting the image into grayscale image, and using which also done using the methods like Gaussian smoothing and histogram equalization optimize image. So in this Gaussian smoothing uh, mainly promotes the image to enhance its quality. Also, the histogram equalization helps to optimize the image for the better feature extraction and human interpretations. So in terms of edge detection and segmentation, so basically edge detection highlights the boundaries between the object by identifying significant intensity changes like two dogs, two different breed of dogs, like German Shepherd and the Pomeranian. Both were sitting near each other, and a camera captured that, converted into digital image. So in this, I just wanted to find which is Pomeranian and which one is the German Shepherd. So this has been done using the edge detection. So drawing the outline for separate, like between those two dogs and the German Shepherd and Pomeranian, drawing a two line like edges between those things, and we can easily find with those line, we can find two dogs. Then after processing few more steps and segmentation, we can find this Pomeranian and this one is German Shepherd. So that minute changes or intensity changes will be done using the edge detection. And segmentation partitions so an image into meaningful regions, facilitating object isolation and classification in complex senses. Like classification will be giving the result in terms of binary forms like yes or no or zero or one or true or false. So morphological operations. So what is morphological operations? So which manipulates the structure of images based on shapes, triangle or any shapes. Like techniques like dilation and erosion adjust. Dilation and erosion, if you adjust that on the object boundaries just to remove the noise or fill gaps, enhancing the quality of binary and grayscale images. So these operations are fundamental for processing along as well as the pre-processing in object recognition and image segmentation tasks. So machine learning in computer vision. So object recognition and classification. So object recognition involves identifying and labeling objects within the image, and classification system use trained models to categorize detected objects into pre-trained classes. So in this, object recognition will be done within the image. Like first, if an image is given, the model will detect what all in that image, like car, person, vehicle, bus, baseball, giraffe, zebra, etc. But in the classification system, it will be just using the help of pre-trained or pre-feeded data. It will compare and it will classify the objects like in the binary format, one or zero. So effective recognition relies on robust feature extractions and well-trained machine learning algorithms. So in this, which ensures the high accuracy in diverse environments. So let's talk about deep learning architectures for vision, computer vision. So in this, which involves CNN, like convolutional neural networks, are pivotal for advanced vision tasks. So these architectures automatically learn hierarchical features from the raw data, significantly improves the performance in image classifications and detection and segmentation compared to traditional methods. Traditional method, which includes the manual grayscale conversion, manual feature extraction, manual edge detection, etc. So image and video analysis. So in this, image and video analysis encompasses tasks like motion detection, object detection, tracking, and behavioral recognition. So integrating temporal and spatial information enhances the understanding of dynamic senses, and which is critical for surveillance, uh, autonomous systems, and multimedia applications. I'll show you a project which involves the image recognition with the help of CV, computer vision. And here is those code for that analyzing and the extraction of the module from that online. Like OpenCV Bootcamp is the one of the module which have been used for the object detection, and main algorithm or model which have been used for on this project is mobile and P2. So which uses the Coco data sets. Coco is an already Coco contains 1 million plus data or image data. So with those things, I'm just extracting the features in those things, and here this represents like identifying the object, and then it will mark a box on it, and then like green color box, any color we can give, and then it will tell what object it is, description of that object. So this is the code for that thing, and this is code for grayscale or the pixel values conversions and the matrix calculations. So here is the one image which I have been feeded to the model, and model predicted the images or the objects in the image. So in this image, a car is detected, person is detected, and bicycle is detected. So over here, rectangle is or square or shape has been drawn and it has been detected. So this uh, so here this code used for drawing the triangle or the box over the image. And one more image have been feeded, and this image shows the person playing baseball with using baseball bat and the baseball ball and baseball glove. So here the model simply identifies this object, baseball bat. Then, with the help of knowledge feeded already, it predicted gloves, but baseball gloves. It has been predicted baseball gloves, not the gloves. The help of knowledge feeded already, and the person and the ball has been detected using the computer vision. And one more image has been feeded for pattern finding. So here, a giraffe and the zebra was in the image. Here, the model correctly identified which is giraffe and which is zebra with the help of patterns on the object, like already fed to the model. If this was the pattern, it's in zebra. If this was the pattern, it's in giraffe. Even the giraffe is bent at its neck. It would be like model has been identified or using the patterns, and it detected it's an giraffe. So in this is what all about image and video analysis. So applications and challenges faced in the computer visions. So applications. Let's talk about applications. So computer vision has been used in autonomous vehicles, also in the robotics. Like it is crucial for autonomous vehicles and robotics, providing real-time perceptions to navigate environmental safety. Like if a person is driving in a car and if a person feels drowsy and if he closes his eyes, the help of the camera, the model will detect the continuously monitoring the person, and if a person closes its eyes, so model will pre-process it, and in a fraction of second with the help of the speed process, the model will give an alarm to the person, like a small vibration or small voice alarm toward inside the car, so that the person will be like in conscious to drive. So over here, the see computation used for drowsiness detection and fleet check detection, reverse parking detection, and all those things, etc. So basically, it's crucial for real-time perception to navigate environmental safety, and it enables the object detection, obstacle avoidance, and sense understanding, avoiding automation and operational reliability in these fields. Also, it has been used in the medical fields, medical imaging and diagnostics as well. Like vision technique assists medical imaging by enhancing image clarity and supporting automated diagnosis. And these applications include tumor detection, organ segmentation, and anomaly identification, improving diagnostic accuracy and patient outcomes through computer-aided analysis. So, in terms of challenges, the main challenges has been faced is ethical and privacy considerations. So, these deployment of computer vision raises important ethical concerns, including privacy invasions and bias in algorithms. So, responsible use entails transparent data handling, fairness in model training, and compliance with regulations to ensure ethical standards are met.